and the last little bits tested out real quick. Looks like everything's going well so far. I am over in the chat as well, so you guys should be able to see everything. Looks like everything. Yep, so everything seems fine there. All right. So first off, I want to apologize. I was going to stream last week, but some stuff came up. I unfortunately was busy with some stuff that's coming up, and I'm going to explain that real quick now, and I'm also going to repeat this at the end for anybody who joins afterwards. But long story short, I am actually getting ready for a major move across the country. I am preparing to move to Seattle. I'm taking up a job out there with Amazon. Let me test the RCO again real quick. Make sure that's working. Yep, cool. Alright, so now that everything's all set up, yes, I am moving to Seattle, picking up a job with Amazon. And so I will be, unfortunately, this is going to be a mid-season break, is what I'm going to do, just to kind of let me move out there, get adjusted and situated. We'll pick this back up early May at the latest, but I might do it a little bit sooner depending on how time permits. And again, I'll repeat all this at the end. If you have questions during this, just put it in the chat and we'll go from there. But yes, so as a result of this whole move process, I am going to be taking a short little break to focus on getting my stuff moved out there, getting myself situated, so on and so forth. There might be one more episode of this between now and next weekend. And if that's the case, it's going to just be a very brief thing. But for right now, this is going to be the mid-season point. We'll pick it back up. And so what we're going to end on today is model loading. So the end result of what today's video is going to give is going to look like this, which is a full-screened application. You'll notice I've got the mouse moving still. The room is slightly bigger. We've got this giant Suzanne head that's just a giant monkey head that's been loaded. The 3D model that Blender has by default. There's no texturing, it's just the colors of how I've set everything up. Look kind of cool, so I kept it that way. We're also going to do some stuff with textures a little bit more. We're going to make that a little bit clearer, which you can see it's really clear. We're also going to make it full screen and add in some very, very basic anti-aliasing. That's why everything right now just looks very, very smooth. So, yeah, so that is what we are going to do, and let's go ahead and get started. So now, if you remember from, whoops, so if you remember from last time, what we did was we created this little guy right here, which all it does is it's just our basic room with some movement. It's in a smaller window. There's not a whole lot of going on. There's no anti-aliasing. And there was also some questions that have been posted around. So you remember last time, and I want to discuss this first because I promised I would, and I feel like it's important to discuss this first. So last time we had discussed with our textures, if we come over to here, we go to our load texture method. We had talked about how we were doing our filtering. So you remember that as you get further away from the texture, okay, it has to zoom out effectively to make the texture smaller, and so we have different types of sampling. And we used, for that minimum filtering, the linear mipmap, the trilinear mipmap filtering. So we have to generate our mipmap, and we also do a trilinear sampling on that. And then for our magnification, when we get closer, we just do a normal trilinear filter. So one of the questions that had come up, and let me bring up the page that had sparked this. Apologies, I need to find where I put that page. Here we are. So it was this page right here, which had brought up this discussion. So on this page, the discussion was, so we have a couple different filterings. We have linear, which is what we're using, specifically trilinear. Anisotropic filtering, which is another type, and mipmap adding on. So we had done trilinear with mipmaps, but there was a question of what is anisotropic filtering used for. Now I kind of dismissed it. I didn't really think it was that important, but a user at that point asked me, you know, what is it? What is such the big deal about it? Should it be used? All of that. Now, OpenGL does not support anisotropic filtering at the it does not support it as a core feature. It is technically still an extension. The big thing is that it is supported by pretty much all vendors. You're going to be hard-pressed to find a modern graphics card that does not support anisotropic filtering. So what exactly is it? Anisotropic filtering, which is going to best be visible on the Wikipedia page, is basically a way to get better viewing of a texture at an angle. So you'll notice that with just trilinear, you can see really well the texture here. Here at this point in the middle, it gets a little blurrier, and then as you go further and further, it gradually gets blurrier and blurrier until you really can't even distinguish at that point what exactly this texture should look like. Now, with anisotropic filtering, what it basically does is it makes it so you can view it at an angle. Now, in our application currently, it is a little blurry at an angle, and so this is actually going to be a filtering that will apply, but again, not all graphics cards support it. And so what we actually have to do, there's a couple of steps to this. And what we're going to do first off, I want to make sure that we can see this. So the first thing we're going to do is we're going to go ahead and we're going to adjust our application to be able to be full screen. The reason is that this is going to make it much, much easier for us to see our any issues we have. So you remember right here we had that we were putting it in a window previously. What we're actually going to do now is we're going to adjust that so that now we are going to make it a full screen borderless window, okay? Now this is there's a reason for this. I don't like dedicated full screen apps. I think it's kind of a pain to deal with when playing a game because it kind of does all this weird stuff when it full screens and you can't alt tab out of it. So what we're going to do is first off we're going to replace that flag right there with the OpenGL flag, window OpenGL flag. Then what we're going to do is we're going to go ahead and say that this is a borderless window. Okay, that means that so if you remember, if we open it up right now, what you're going to see is that it's in this window and that we've got our minimize, maximize, and close button. So what this is going to do is it's actually going to get rid of those options, because really in any game you don't want those. They're not going to be visible when full screen. Then what we're going to do is we're going to go ahead and one more flag, which if we come over let me bring up that screen again so you guys can see. Here it is. So there are a few different options here. The first of which is borderless, which we've already done. We have the OpenGL. Finally, the final thing we want is SDL Window Maximized. So what this is going to do is it's basically just going to maximize the window. And because of this, when we open it up, you'll notice that it is full screened, it's no border. We can alt tab out of it without any consequences. Because of the way that the application is set up, it's not actually taking over the resources. So we can do all of this still from there. And to kind of show the difference between this and a normal full screen window, let's go ahead and what I'm going to do is I am going to very quickly just do full screen desktop. Okay, so what that does, full screen, we'll take it at whatever resolution we pass in, which is the resolution with height. We actually just want to use the desktop's resolution. So we'll go ahead and we'll do that. And what that's going to do is, it's going to break real quick first. Oh, come on. What the heck? Come on. What did I just do? There we go. That's the closed. Which one is which? There we go. Broke the project. Alright, let's open that back up again. Let's come over to, where is that? Window. And window full screen desktop. What we want is we want OpenGL. So that should hopefully be okay now. So now you'll see that we have this full screen window, but if we go ahead and we Alt-Tab, you'll notice that one, we can't display stuff over top of it, but also there's this almost like flicker very, very briefly when we do this, and that the window itself is moving around. It's a very weird effect. The reason that is there is because it is doing it's basically gaining resources. It's a weird thing to explain. I don't really want to go fully into it, but basically the way that I generally do this is I do window borderless and maximize. And in a normal game, you'd have the option to do either or, and then of course adjusting the screen resolution and all that fun stuff. But this is just the way I do it. You'll notice now it's perfectly fine. We're not getting that that weird mouse movement. So now that we've gone ahead and we full screened it, let's go ahead and look at some stuff. So if we go ahead and we look at our texture head on, it's pretty clear. We can get pretty close and we can see a little bit of pixels and such, but it's nothing crazy. The worst is, I think, the letter E here and S. Anything with curves, you can kind of see it worse. But if we back up, it looks fine, and the further back we go, if we come all the way back here, move our mouse around, there's not a whole lot going on with that texture. Now, where you'll notice it is if we come over to this angle here and we back up, you'll notice that it starts getting blurry. It's still readable because the font's very large, but it's just not very clear. And if we get to this point, you'll notice that that text is really blurry. It's kind of weird as well because like the rest of the lines and such are in focus, but it's just the text. Now this is where anisotropic filtering really comes in handy, because at this point what we need to do is we need to set it up so that our texture is going to be filtered, it's going to be sampled better on the side. And this is of course going to be in addition to the MIP mapping that's already going on. So what we want to do is we want to come over here to our drawable, go to our texture method, okay? So right in here, what we want to do is we want to go ahead and check whether this extension is supported. Now the extension is actually, let me bring up the page for that real quick, is this right here. It is gl_ext_texture_filter_anisotropic. And what this basically is this is a this is what the extension is actually called. This is the name of the extension to allow for that type of filtering. So what we need to do is we need to have OpenGL query for whether or not this is an actual thing that we can use on this graphics card. So what we're going to do is we're going to use glue is extension supported, and we're going to then quote that thing. So basically what this is going to do is this is going to query the graphics card and say, hey, can I go ahead and use anisotropic filtering with this graphics card? And that is how you can go ahead and check whether it's supported. Now, once you know whether it's supported, you have to realize that anisotropic filtering has multiple levels at which it can be done. So going back over to here, there's multiple levels at which it's done. I don't know if this discusses it, but what we can do is we can come over to here. This is a little document I found online that kind of digs into it more. And this kind of goes over what I'm going over as well. But basically, what we want to do is there's multiple levels you can do it at. You can do it at just one level, which is like basically none. You can do it at the highest level on some graphics cards, which is 16, which is what mine supports. But not all graphics cards support the highest level of 16. So what we now need to do is we need to actually go through and get what is the largest value for our anisotropic filtering we can use. So what we're going to do is we're going to create a float here. I know that this is not the best way to do this, and of course in future code you'll want to do this elsewhere, get the largest value and then set it up that way. But we're just going to do it here, which is largest, and still not used to this word, largest anisotropic. And what we're going to then do is we're going to do gl get float v. So we're going to query for the max texture max anisotropy extension, and then we're going to pass in this right here. And what this is going to do is this is going to now ask, okay, so we asked the graphics card, is this a supported extension? And then we're going to say, okay, go ahead and tell me what the largest anisotropic value we can use is for sampling. What's our largest sampling value, effectively? for this graphics card. And then once we get that, what we can do is set our text parameter F this time instead of I, texture 2D GL texture max anisotropy extension, and then we're going to use our largest filtering value. And of course, in most games, you'll actually be able to change that setting. You'll be able to adjust how big of a value you want to use. Maybe, if your graphics card supports the largest, but it's not able to do everything else, you can substitute that. In this case, we're just going to go ahead and keep it like it is, so that we can always have a so that it just kind of looks nice throughout this. But of course, you can always change that. So if we go ahead and we do this now, what you'll notice is that if we come over to the side of this texture, even as far as right here, it does not look blurry. It looks much, much clearer. Still, of course, a little bit weird because we're at such an angle, but it's much, much more readable. Whereas before, if we go ahead and we don't set this value, so we just comment that out and rerun the code, as soon as we get over to the side here, you'll notice that it's just really blurry. I mean, you can see that blur really bad. Right here, I mean, I can barely read that. If we go ahead and we come back and we do that again, get to that same spot, you can still basically make that out. And yes, it's not perfect, but it's much clearer. And even in real life, you'd have a hard time reading that. So this is what this looks like. So that is our filtering. The next thing that I want to discuss now is I want to discuss model loading. So model loading. There are a variety of formats out there. There's tons and tons and tons of different formats for models. All sorts of different ones you can use. However, I wanted to focus on a couple things. I wanted to focus on a model format that is nice and readable. We don't have to worry a whole lot about things like, is it readable in a... I don't want to work on a binary format, basically. I don't want to be dealing with weird loading things into memory and adjusting offsets and all that. I wanted to make sure it was something that was readable from our perspective. So what I did was I'm going with personal little one that I always use, which is OBJ. So OBJ models are nice and easy. You can actually create them in Blender. So I've actually got Blender 2.76b loaded. And this is what Blender looks like for those of you who haven't used it. It's basically a 3D modeling program. It's very, very awesome. It's completely free. I highly recommend it. I'm sure there's going to be people who dislike it. You're welcome to voice your opinions on this, but it's free, and I prefer that to others as a result. So what we're going to do, we could use this cube, but I think the cube is a little uninteresting. I think that monkey head is going to be better. In Blender, there's a little object called monkey. It's construct a Suzanne mesh. That's kind of one of their little preset models. So what we're going to do is we're going to go ahead and we're going to generate him, and then we're going to go ahead and we're going to move him up on the z-axis by 1 point. In Blender, something to keep in mind, okay, is that you have our x-axis, which is that red line. You have our y-axis, which is actually going forward and back in Blender, and then you have z, which is up and down. This is counterintuitive to OpenGL. OpenGL is our x-axis like that, but our y-axis is up and down, and our z-axis is forward and back. So that's something to keep in mind when you're doing this. When you export your model, which we're going to do in just a few minutes here, you'll have to do that as well. So let's go ahead and we're going to take this model. You come up to File and click on Export, and then come down to Wavefront, that .obj extension. And what we're going to do is we are going to come over here. I'm going to go to Live Stream, Demo Project. Whoops, is that not where I put it? No, it's over here in Visual Studio, Projects, Demo Project, Demo Project, was it Demo Project? And then I think I just leave them in the top directory, top level right now. Let me double check that real quick. Make sure I put it in the right spot. Yep, just in that top level. And we're just going to name this test.obj. And now what we need to do is we need to do a quick few adjustments to this model. So what we want to do is we're going to want to first make sure that our forward direction is -z and our y is y up. Our up is y up. This is because, again, that Blender's coordinate system is a little bit different from what we use. So that's the first important part. The next part we want to do is we want to make sure we're writing out the normals and the UVs. We also want to make sure we triangulate the faces. OBJ models can actually have 4 coordinates to their faces instead of the normal 3 for triangles. It can be quads instead. We only want triangles because, again, that's going to be more efficient for our rendering. So once you've gone ahead and done that, the last thing to do is by habit get into the habit of setting the path mode for your textures to relative. A lot of models get exported and they set it to auto, which basically when you're loading your textures and it associates the textures, it doesn't do it well. It's really, really annoying. So go ahead now and click on export, and that's going to go ahead and generate an object for us, which if I come wrong spot, we go ahead and open this up. And so that's going to look something like this. And so this is what the actual file for our object looks like. You'll notice that there's a lot of data here, but it's all actually pretty readable. So this model is a little complex. You won't be able to understand it as well, but I can't either. But basically the way to look at it, so these first 2 lines are comments. Comments in the OBJ model format start with these little pound symbols, the hashtag symbol if you want to call it that. And basically these are lines that are just kind of ignored when you're processing. So anytime you see one of those, it's nothing more than a comment. Let me make sure that my stream is going okay. Make sure everything is loaded okay and that everything's playing okay. Yep, okay, everything looks to be fine. So this is what a comment is. This line right here is basically telling us that we're using a material. So if we go ahead, we can come down here and we can open it up, the Mtl file. The Mtl file is a material. Again, similar format with comments. We'll go over this in a second. But basically, this is what defines your textures and such, so that when you are loading your model, you can see all the textures and stuff with it. Then we have the O line right here. So basically the first sentence of each line is, the first word is each one of those defines what exactly is being done here. So in this case, Mtl lib is basically saying we're using a material now. O stands for object. You'll remember when we exported, I don't know if you guys saw that option, but one of the options that was checked off by default, and this isn't huge, but is objects as OBJ groups. So basically this object group here is called Suzanne because that is what we created. You can of course rename this to anything you want in Blender. To do that, all you have to do is come down to here and just rename this object right here. And that is what is actually used. So that's basically just saying that this is the start of our Suzanne model stuff. Next we have V, a whole bunch of lines that all say V, and then 3 floating point numbers, 3 decimal numbers. So each one of these basically is a vertex point. So you remember that all of our models are, all of our 3D objects are made up of vertices. If we come over to our test object, test shape, you'll remember that we have all of these data here. We have our vertices, we have our colors, and we have our UV coordinates. So the V corresponds to those positional coordinates right here. And so these are basically just a whole bunch of vertice points that are being defined all the way down. You keep going down, you'll see that they go on for quite a while until right about here. So those are all of our vertex points for actually having the 3D model created. So then we have Vn. Vn stands for Vertex Normal. Now we haven't gone into normals, we haven't really gone into lighting and things like that, but this is what's used for lighting your model and being able to do shades of different colors and stuff along it. The normals are something that I didn't really use in this, mainly because we haven't really gone over lighting or anything, and we'll go over normals later, but just know that this has normal data as well. The final thing that we have, and we actually can't see it here, and there's a reason for it, but we actually can generate texture coordinates, and we're going to go over that in a little bit. I wanted to kind of introduce the basic format, but it's basically another value, vt, and it can have up to 3 values as well. However, we're actually just going to use 2 because that's what our models use. Next, if we come further down, you're going to see that we're going to use material none. This again relates back to this texture here. You'll notice that the material here is none because there is no texture for it. S basically is saying that there's the smooth shading is off, or that I think smooth shading is off, I believe is what that stands for. Again, we're going to be ignoring this because we don't need it. Finally, we have our faces. So now that we have all of our data loaded for this mesh, what we can actually do is we can define faces, and each face basically specifies 3 things per vertice. So we have 3 vertices. Each of those have values that are separated by those forward slashes. The forward slashes start out with our vertex point, then we get our UV coordinates, and then we get our normals. And so each one has this. So we have the vertex, UV, and then normal, vertex, UV, normal. And so then we go through, we read all of these, and then we can generate our mesh. Now, you'll notice again that we don't have our texture data. There's a reason for it. So in Blender, you'll notice that we have our model, but we don't know how to lay out the coordinates for the textures. We need to actually texture this model in order to be able to generate coordinates, and we have to tell it how the texture should be wrapped onto this model. So this is done through Blender. It's a pretty, I'm pretty cheap about it. I just end up using their automatic unwrap function, which basically unwraps the model and creates our UV coordinates for us. So if I go ahead, I'm going to split up into this tab. To do that, you just click on this little line thing in the top right hand corner, and then we come down here and we go to UV image editor. And you'll notice the other thing to make sure, you start on object mode, which looks like this. You want to switch over to edit mode, which will show you all of the little points, vertice points on here. So go ahead, if you aren't selecting all of them, go ahead and push the A button, A key on your keyboard, and that will select all the vertices. Once you've got all the vertices selected, go ahead and do Mesh, UV Unwrap, Unwrap. And what that's going to do is that's going to unwrap all of those vertex points from your model. So if you go ahead and deselect those, what we can actually do is we can only select these ones, for example. Oops. So let's go ahead and select some of these here. I don't know if it's going to let me select these. There we go. So if we come over here, well, so what we can do is we can go ahead and, oh, it's not actually matching up like I thought it would. But yeah, so this is what UV unwrapping does. Come over here real quick. Try Smart UV Project. It's pretty cool. Yep. So that's another way of unwrapping data. So if we go ahead and we undo that, oops. Forgot that you have to. Selecting objects on this counts technically as UV unwrapping. So if we come here and we do UV Smart UV Project, we go ahead and select OK. That's going to go ahead and do a little bit more complex unwrapping. Basically, there's a whole bunch of different ways to do it. You can really do it in any way you want. You can do cube projection, which is kind of cool. It tries to unwrap it like a cube. That's actually super useful if we actually have a cube object. So if we go ahead, we'll delete this, and we go to cube, and we do object, go into edit mode, and then do mesh, UV unwrap, cube projection. We get this cool little cube where we can see each of the faces. That's a pretty neat one. I generally don't. I generally stick with the mesh, UV unwrap, unwrap, and that kind of does an okay job. You can also do UV unwrap, Smart UV Project, that goes ahead, and that's kind of nice because it gives us each of our faces. Whoops, did I not? So now you can see if I go through and I select the faces, it kind of highlights them over there. Why does the projection have 6 faces? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And the reason that it has 6 faces is because it's a cube. And that's one of the nice things about this smart unwrapping. Whoops. Yeah. So basically, there's a couple things. I forget that the video is delayed, but basically, if we go ahead and we unwrap like this, you'll notice that it doesn't show up very well. The reason is that basically the faces are overlapped. I like to keep it like that. That's why we have to do UV Smart Unwrap in order to actually see the different faces. Yeah. Sorry about that. I misread. It's all delayed, so it's throwing me off. Oh wow, it's actually showing people on the IRC finally. Sorry guys, everything's all delayed and stuff, so. But yeah, so what we're going to do though is we're going to use, rather than use a cube, we're going to use Suzanne because I like the look of her better and it'll be a little easier. And again, we have to, I'm going to go ahead and move her up because the reason I move her up like that is because if we leave her in the ground, technically she's now going to be through the floor in our game. So what we want to do is we want to move her up a little bit. Next we'll go into edit mode, go to mesh, UV unwrap. We can go ahead and do smart UV unwrap. That's one way we can do it. And again, if we select the faces, it's kind of nice because we can actually see over here where exactly we're selecting as far as the UV coordinates go. So now that we've gone ahead and done that, we can go ahead and do export, wavefront OBJ, test OBJ, export. And if we come back to our file here, you'll now see that we have texture coordinates, and they're in pairs like normal, like we would expect. So now we have all of our texture coordinate pairs. And so if we come back down to our faces, you'll notice that our faces now each have 3 points per coordinate. So we're all set. Now, for this video, the OBJ model format is not perfect. It's nice and readable for us so we can kind of get a feeling for how to store model data, but there's some flaws. So first off, before we go into that, we aren't going to be loading the materials. The reason being that honestly, I don't really care about the material texture stuff. We're probably only going to use this briefly for this tutorial as one example of how to store model data. If you want to implement those, though, it's pretty easy. The things to remember is that there's multiple types of textures, and specifically the one that you will want to use. And I don't think I have any textures I can go ahead and use. Come to demo project, and we can just go ahead and texture with that. Open image. So there's that. We'll go ahead and we'll just use that awful image. And now let's come into material mode. I'm going to go ahead and show this real quick, but we're not actually going to use this. So the way that you can texture an object in Blender is you come over here to this tab right here with the little circle, and you have to create a new material. Once you've got your material created, you'll be able to come over to this texture side. You'll be able to then select on the texture. You'll want to use UV coordinates, flat, type, image or movie, and then the image you'll want to use is that. Now that we've got that, if we go ahead and we go into object mode, and we're going to switch from material mode to just texture mode. And then we need the light source to be better. So now you can see that we've got our monkey textured with that carpet texture or the bathroom countertop texture that I was using before. This is what it looks like when it's fully unwrapped. And now if we go through and we do export, OBJ, export there. So if we come back into here, you'll notice there's a couple different values, and there's also this map KD that then also has our texture image name. So this is where one thing I'm going to cover just real briefly. We're not actually going to do this in our program because, again, I don't really want to deal with it. But basically, map KD is a very specific type of texture. What is the... KD. What does that stand for? It's the KD value, but it's a type of... It's a specific color type, effectively. Basically, the KD value is when you're doing colors of an object, you blend multiple colors together to get a specific looking material, effectively, and the map KD is one of the materials. There's multiple types you can use. This is basically just the normal color space, and this is what you'd want to use for your normal texture. There's other types of ones you can do. You can do bump mapping with this, all sorts of stuff, but again, we're not going to dig into that. I don't really feel like going into texturing with this, because again, we're probably not going to use this model format anymore after this. We're going to be switching over to using a library that loads it all for us and makes it all pretty easy. But it's pretty easy to go through and parse it if you want to. You can use what I'm going over in this video to do so. But for now, let's focus on this, which is how do we start parsing this model? So to parse this model is it's pretty straightforward, but at the same time it's a little counterintuitive based on how we've been doing OpenGL. So obviously the first part is to load all of our vertex data. Basically, and Ray March points this out in the chat, so I'll go ahead and repeat it. There's ambient, diffuse, specular, emission. I think that there's probably others as well, but those are kind of the four main ones. I forget the specifics of each one. We'll go over that when we get to lighting, because that's where it comes into a little bit more play. But basically, there's ambient lighting, there's ambient colors, there's diffuse colors, there's specular, and then there's emission colors. And all of those get combined to do it. I think that, based on what I remember, D is for diffuse, but I'm not entirely sure. Might also be ambient for some reason, because I remember that these names might not match up, and I don't know why I'm remembering that. I hope I'm wrong, but it would not surprise me if they don't. But yeah, basically there's multiple colors. And Ray March, I believe last time you asked about anisotropic filtering. I don't know were you here at the beginning of that. If you weren't, just let me know and I can repeat what I said about that, because I did do the research for that and got some information for you. But to kind of continue on real quick, so we need to load our vertex data. We need to then load our vertex texture data, our UV coordinates, and then we're going to load the normal data, but we're not actually going to use it. We're just going to kind of chuck it off to the side. And then once we've loaded all of that, we then have to generate our model with our faces. Now, I don't know if anyone's noticed this already, but we're already running into a problem because OpenGL handles this data differently. So you remember with our test shape, we loaded in the vertice coordinates, the colors, and then the texture data. And each element, all of them were joined together in that manner. And we could reuse them as need be. Okay. So you looked it up yourself. When this video is on YouTube, you'll be able to see you'll be able to watch it, and we added some basic anisotropic filtering to this. So yeah, but continuing on, you'll notice that for each element, there's a very specific 1-to-1 ratio for the vertices, the colors, and the texture coordinates. Whereas over with our OBJ model, we can mix and match them in any way we want. So for example, the coordinate for the positional data for 47 can match up with 1, but then further down it could technically also go to 2. Or in this case, it could be 47, 1, 1, or it could be 47, 1, 31. And this means that when we create our model, we actually have to mix and match it all and then reload the data into it. So this model format's not the most efficient, it's just very easy to read through and understand, which is why I picked it. Again, we'll be using more efficient model types later on, but for right now, we're going to focus on using it like this. So let's start actually coding all of this. So the first thing we're going to do is we're going to create a header file. This header file, and let me go ahead and bring this over here so I can see that, and I want to make sure I type all of this right on the first try. So we're going to go ahead and create our header file, and it's just going to be called objloader.h. And we're going to come down here to our source files, add new item, and then objloader.c++. and we'll go ahead and move this over here. And now let's go ahead and start actually creating the class. So there's a few different things we're going to need. The first of which is we're going to need to include our string. We're going to need to include string stream. We're going to then also need to include IOStream for file loading input output. Then we also need to include fstream. We need to include an unordered map, and you'll see why that is in a little bit. We also need to include some of our GLM stuff, and we need to also include drawable.h because this is a drawable object, and we need to include shader.h in order to be able to get the attributes with the file. So once we have that, let's go ahead and make our class obj loader. We're going to make sure it's public so that our drawable methods like draw and such are usable. We're going to have some public stuff and some private stuff. The public, all we're going to have is our constructor, which is going to take in a shader pointer. And then we're going to have a string file name for loading our file. For some of our private stuff, we're going to have a handle vertex data method, which takes in the string type. We're going to have our float x, float y, and float z for the different data types. Finally, we're going to have our handle face data, which takes in a string, which is triplet, which is that comma separated values from right here. So we have 3 points all separated out, so that's our triplet effectively. Finally, we're going to have a few different variables. We're going to have our file stream, and actually all of this does not actually need to be in there. It only needs to be in that section. So the only things that we really need to keep track of, we need to, if we desire, we can have a texture. But again, we're not going to be texturing this. So what we're going to want to keep track of is our element ID, which as well should not actually need to be kept there. We can keep that separate. I'm checking from my code done before and making sure we do this one. So the only things that we really need are GL, INT, position, attribute, we need our UV attribute, and we need our color attribute, which is going to be what we use for tracking everything. So let's come over here. We're going to do include obj loader, and then we're going to have our constructor first. Shader, string, file name, and let's come over to here. Make sure I include all the right stuff. So we need to include a few different things before this. However, we need to include windows.h because, again, we're doing some Windows specific stuff. And we need to include gl/glue.h. And that's going to fix our stuff over here for the glint. So now that we've gone ahead and we've done all of that, we need to declare a few variables that we're going to use when we're loading the file initially. So we're going to actually have first our file stream. So if stream file, we need our string, not our string stream, which is going to have our data stream. We need vector floats for our vertices, vector float UVs, and then we need a vector of our final data, which is going to be constructed from a combination of vertices and UVs based on the face data. And then we need to also have a vector of unsigned ints for our elements, which are going to be pushed into our element buffer object. Finally, we need an unordered map that consists of strings and unsigned ints. And this is going to be elements cache. Now remember, we might reuse multiple elements per face, and so we want to actually keep track of all these elements so that we're only loading them once and then into our vertex buffer array object, our vertex buffer object, and then once we've loaded them into the vertex buffer object, we can reference them with our elements multiple times. So Finally, the big thing we need is we need an unsigned int element ID, and you'll see where that comes into in a little bit here. So that is all of our basic data. Now that we've got all of that going, we want to set element ID to 0. We want to open up the file, so we want to do file.open this file, file name, and the mode for this is going to be stdios in, because again we're just reading it as a text file. Now what we want to do is we want to check that the file was successfully opened, which if it was successfully opened, we're going to start out by getting a string variable line. And what we're going to do is we're going to read each line of the file line by line. And as long as we're reading, we're going to be able to go through and get data. So next up, what we want to do is we want to go ahead and create a string stream. So we're going to do is string stream line substring 1, and that's basically going to go ahead and get rid of that first character in our string stream, so that because we're already done reading it. Now once we've gone ahead and we've gotten that, what we want to do is we want to take the first character from that line, and we're going to do different things based on what it is. So that first character, the first instance is a comment. We're not going to do anything. We're just going to leave it as is. If we get a v, however, what we want to do is we want to then read the x, y, and z coordinates that are a part of that. And what we're going to do is do string stream x, y, z. And what that's going to do is that if we come across a line like vn, it's going to say, okay, there's a v as the first character. What we then want to do is we want to go ahead and read each value afterwards. So we're going to read our first coordinate, our second, and our third is x, y, and z. And so notice that those are floats. That's very important to make sure that you keep those as floats. Finally, what you're going to do is this handle vertex data, which you're going to pass in the line, the x, the y, and the z. So next up, we have case f. And this is where we're going to then handle our if we get an F, we're going to want to go ahead and get our triplet, that triplet being the 3 values right in here. Notice that these are space separated, so we can actually go ahead and create our triplet, and then we're going to do wall string stream triplet, this handle face data triplet. Because again, each of these points is going to end up being a triangle in and of itself, but then each actual value here is basically just another point into that face. So once we go ahead and we do that, what we're going to then do is we're going to implement these methods, and what these are going to do is these are going to pull out all of our data and such, and they're going to store. So there's going to be 2 parts to this. First, we're going to go through and we've already done the file reading, we've gotten the data streams and such. Now we need to then what's going to happen is we're going to store all of our data in our vertices and UVs. Finally, we're going to use the vertices and UVs, and each time we read a face data value, we're going to put it into the final data, and then we're going to put it into the elements. But if it already exists in our elements cache, we're then just going to reference that. Our element ID starts at 0 and increases every time we get a new and unique element value. And you'll see what I mean by that as we go on. The final result is that our final data is held within the final data, and our elements for our element buffer object are held in elements. So once this is all done, what we can then do, we come down here and we do our bind VAO like normal, this load vertices, this final data. So that'll go ahead and load our final data, and then we do this load elements, and then we can go ahead and start our shaders stuff. So we do position attribute is equal to shader get attribute position, and this is all basically pretty straightforward. We can actually come over here to our test sheet, and we can actually copy most of this and be okay. So rather than wasting time, what we're going to do is copy that over, and then we're going to come over here. We need to just make sure that our variables are correct. So we have that. So we have position, color, so on and so forth, and then we have position. And actually, it's probably going to be a little easier to just do it this way. We'll rename everything in accordance here. So there's that. There's that. So now that we have each of those, we need to remember that our position attribute here is not actually going to be 2 points, it's going to be 3, and that's going to increase all of these to 8 as a result. And then as a result here, we need to up that to 3, we need to up that to 6. The reason being that our offsets have now changed, because if we look over here, we have 3 points here, so then at this next offset it's going to be another 3, and then our UV attributes are just going to be too long still. So now that we've gone ahead and done that, we can go ahead and unbind the VAO, and then finally we can start clearing everything. So we can do vertices.clear, UVs.clear, final data.clear, because again, all of this is already loaded into memory. There's no need to keep that around. Then we can do elements.clear, elements cache.clear, data stream.clear, and finally file.close. And so now the only thing left is we have to go through and implement our handle vertex data and handle face data. So the vertex data is pretty straightforward. What we're going to do is do void obj loader handle vertex data. And this is going to take in our data as we said here. So we're just going to copy this, and I'm going to make this nice and easy by just copying that. And so this is pretty easy. All we're going to do is do switch type 1. And basically, if we get a case where we get a T, that's obviously our UVs. So we're going to then do, and actually we do need our UVs and vertices to be stored here, because we need them accessible in the other classes. Getting a comment. Whoops. There we go. Lines there. So now that we have that, come down here real quick, make sure I specify this so that anybody who reads through can see pretty quickly what each part is. Cool. So now what we want to do is we want to do this vertex UVs dot push back X. We're going to do the same thing with the Y. Nope. Did not actually go through all the way. There we go. So if we have a T, we push all of our UVs back. Then if we get a space, what that means is that it must be one of these normal vertex coordinates. So if we come up here, you'll notice that this first character, the second character, the first being the second character in this case, because it starts at 0, yada yada, is going to be a space. So if it's a space, then we want to add this to the vertice, vertice list. So we're going to have X, Y, Z, and that will go ahead and store all of our vertex data. So pretty straightforward. Next, let's go ahead and do our face data. So we're going to do that, obj loader, and now that we have this method, this is a little bit more complex because it's separated out by those slashes instead, and the way I did this is a little hacked together, but it works. So we have our values there. We're going to have another string, and we're going to pass in that triplet, and we're going to have a string token, which is going to be what is actually read out. So the first thing we're going to do is we're going to do std get line. We're going to pass in the string token, but instead of a space, we're going to use our slash, and then we're going to set b is equal to So that basically what that does is that parses that string. So we have like 47/1/1, so we'll get that 47 right before the slash. So now what we can do is token is stored as 47. It stores that 47, so we need to do std stoul. So that's basically string to an unsigned integer. And so then what we're going to do is to pass in our token, we're going to say 0 and 10 because the index, the offset in the string is 0, and the conversion is going to be base 10 decimal. And that will go ahead and get our v, and then we need to do the same thing with vt and vn. And that's going to be the exact same stuff, except now it's going to be a different storage there. So now that we've gone ahead and done that, what we need to do is we're going to come down here, we're going to create a string element string. This is going to be used for our cache, so we're going to have std2 string v, and then we're going to do the same thing to vt, to string vn. And that's going to store a string that has our v, vt, and vn's combined. What you can do, of course, is you could comma separate them or whatever else. I'm not really too concerned about that. That should be unique enough. So then what we want to do is we want to do auto element equals this elements. Reminds me we need our elements cache to be within here as well. So we'll go ahead and put that there. There's that. There. So now what we want to do is we want to go ahead and search the elements cache for that element string. And basically, if we get a result of that back, what we actually want to do then, oops, is that not the same name? It should be. Yes, that should be okay. Oh, element cache.find. There we go. So basically what that's going to do is that's going to search the elements cache for a string of that specific name, which is basically saying if we've already added this element to our list of elements, we want to just reuse that. So if the element does not equal this elements cache end, so basically if we don't reach the end, then all we're going to want to do is just in-place back that element's second value, which is going to be an unsigned integer storing that value. So there's that, and again, that needs to be, I keep forgetting to do this, I should have just kept it all the same. Oh well. So again, this needs to be kept within the class like that, so that we can actually see that all. And then there's that. Okay. And then again, we're going to have to do the same thing with final data so that we can actually see it properly. So we'll go ahead and do that. That there. So now that we have all of our so if we do not have that, though, then we're going to have to do some more complex stuff. The first thing we're going to have to do is we are going to have to, and vt, each of these needs to have minus equals 1, minus equals 1, vn minus equals 1. The reason being that each of these are going to be 1, 2, 3, 4, starting at 1 going up. We need them to start at 0 going up. So go and we do that, and then otherwise, if we have not already used that, we need to then otherwise we need to go ahead and actually create that element. So the first thing we're going to do is we're going to take this final data dot emplace back, and we're going to push back the vertices at that point. So it's going to be v times 3 plus I. The reason is that, remember, when we were adding these vertices in, we're adding them in 3 pairs at a time. So if we add in or 3 triplets at a time. So if we add in, 2 elements, we want to get the second, we're going to have our first 3 values for the first one. For the second one, it's going to start at an offset of 3 as a result. And so we need to take that into account, and this will do so. So that'll go ahead and put that there. Then what we need to do is we need to do the colors. So this final data and place back. And what I've been doing with this is I've been doing it with the element ID divided by 256, which the element ID was kept globally before, so that won't work. So what we're going to do is we're just going to make it white to start. We can go ahead and add some fancy colors later. But we basically need to add 3 pieces of color for our color data, because that's the second thing it's expecting. Finally, we need to go ahead and we need to do our final data again, this time with our texture coordinates. And so that's UVs. And remember that we only have 2 vert texture coordinates, so we need to just do 2 instead. So now that we've got that, we can go ahead and do this elements in place back, and that needs to have our element ID, which means that that also needs to be stored class. I keep forgetting to do each of these. So there's that. And that means over here we need to set this to 0. So there's that. So there's our element ID. And what we can do is we can do that divided by, I don't know, like 256 or something. Should be good enough. That should be high enough that we don't have to worry about it. Then we go ahead and we do this elements cache in place element string, and we need to do the element ID currently, and then we do that plus equals 1, and that will go ahead and do it for all of this. So now that we've got all this, let's go over to our test state, and we need to also open up the teststate.h file. And we're going to go ahead and we're going to include into here our new OBJ loader. We're then going to have an OBJ loader object. So we'll come here and do it right there. OBJ test. Next we come over to here. We go ahead and we do this with a new OBJ loader shader. And our file name is just test.obj. Next, we'll take this object and we need to render it. So we're going to render it after we've already set that, because remember we're not going to have a texture, so we want to do it after the has texture uniform is set to false, but before we draw the room. And if we go ahead and we load this up, this should be all that we need for loading our model. And we got an error. So let's go ahead and see where I went wrong with loading this. Probably something really silly. So let's go ahead and we'll debug line by line, see where I went wrong. So we open up that file there. So that goes ahead and does that. Let's put debug statements in each of those. Oh, might help to actually have a breakpoint here. So that'll go ahead and fix that, and do that. Forgot a breakpoint. So we have that. Let's see here. What did I forget to do? Too much data? Shouldn't have. No, I'm forgetting something silly, guys. Apologize. Is it crashing after that? Shouldn't be. Yes, it is. Oh. Duh. Might help to also call the constructor for drawable. So that's the first thing. Okay. Put that up. and there's something going on here with what I'm doing wrong, so give me 1 second to check. There's that. Doing wrong. Let's see here. Is one of the face data's wrong? No, none of the face data looks wrong. Okay, only break out each time there, so that shouldn't be it. Bind VAO, load vertices, load elements, yeah. Final data and place back, yeah. Place back and place back. One other thing I forgot to do, that explains it. Make sure you set that VT times 2, because again, that offset should only be 2. There we go. Oh, sorry guys, it's been one of those days. So now that we've gone ahead and done that, if we go ahead and we let this load up, we see part of our monkey texture. So why is that? And this is an issue that was driving me nuts. I thought that I had broken my code. I was all worried. Everything was working, but this, I spent a lot of time trying to debug that, and it turns out that our monkey's just a little too large for the room. Okay, don't worry, your code is not broken. The monkey is loading. It's just really, really tall. So the final thing that you need to do to actually be able to see it in full, you've already got it all working, you just can't see it properly, go ahead and just set this to have a height of +10, and that'll make a giant room like you saw before. So now, if you go through and you see it, boom. There is our monkey head. We have our texture loaded. Everything looks great. So let's go ahead now and do a little bit of polishing on this. Now that our monkey is loaded, we're going to go ahead and polish this just a bit. So what we're going to do is we're going to add in some anti-aliasing. Anti-aliasing is pretty important because it will just make everything look so much prettier. So what we're going to do is we're going to come over to application.c++, and right before that, what we're going to add in, this is all built into SDL, so all you have to do is do SDLGL set attribute, SDLGL multi-sample buffers 1, and then you're going to do the same thing, but this time it's going to be multi-sample samples, and you're going to set that to 16. That should be okay, even if it's not there fully. And then finally, SDL, we're going to come down here and do GL enable, and we need to do GL multi-sample. And so what this is going to do, this is called multi-sample anti-aliasing. It's going to basically take away all those jagged edges along the lines of our models and such, so that everything just looks a little smoother, so that when you're at a distance, things look better. You'll notice that there's just no more of those jagged lines. Everything just looks pretty smooth. And so this is kind of the end result for right now. This is at this point you have everything you need to do. Pretty basic game. You can do 3D modeling, so you can go through and create a nice little monkey. It's kind of neat. Kind of looks like a wooden monkey stone texture. And if you wanted to, you could even go in here and actually set that up with a texture. It wouldn't be too hard to add on. But this is pretty much it for today's video. Again, I'm sorry I didn't stream last weekend. I am getting ready to move to Seattle for a new job with Amazon, so I'm going to be busy prepping for all of that for the next coming weeks, so there's probably not going to be, I'm going to take a small couple weeks break, and then we will dive back in. As to what to expect in the next set of videos, we're going to be going over a few different things. The first thing we're going to be doing is we're going to be learning how to use Assimp. Assimp is a model loading library for C++. It loads all of these file types, including even OBJ, somewhere listed in here, I'm sure. So OBJ is just a really nice format for reading, but it's not the most efficient. So this will go ahead and do OBJ plus everything else. So we'll be showing you, I'll be going over how to use Assimp at that point. The other thing that we'll be going over is Bullet 3D. So let me go ahead and bring that up, which is a physics engine. It's a very awesome physics engine, very fun. So we're going to be learning how to use this and how to do physics with it. The other thing that we're going to be going over is how to use Oculus Sdk for PC and how to integrate that. I have an Oculus Rift on the way, and so I will be getting that. The other thing that I'm hoping I will have time to go over is how to do the HTC Vive. This is a little bit more complex. I don't have any of their development stuff used before, so we're going to have to wait and see if I actually have the ability, how long that's going to take to actually learn, but I'm hoping I can go over how to integrate that within C++ as well. We're also going to be going over some more advanced lighting. I'll be showing how to do some basic lighting and then how to do some more complex stuff so you can add lighting in your games. And then we're going to actually go through and finally make a game and all of that. So there will be another approximately 9 or so episodes of this. But again, I'm moving. I got to be ready to move. I got to get all my stuff packed up here. So it is going to be a little while, and I apologize for that, but it has to be done. So that's really it for today. At this point, we've gone over quite a bit. We've gone over setting up basic windows all the way to texturing, setting up colors, how to load basic models, how to read them in and get all that moving stuff, and how to smooth out textures, some anti-aliasing with SDL. I think we're in a pretty good spot. I thank you guys for bearing with me. I know that a lot of the initial videos were rough. I know that sometimes these videos are a little rough as well. I try not to rehearse them too much. I rehearse them. I try to make sure I know the code and understand it and can explain it to you guys. But the basic problem in the end is that I want to make sure you guys also see how to debug these issues, how to understand them, how to not get too stuck on them, being able to figure out where your code is going wrong and things like that. And so I'm planning to change it up after this season, because after this season I think we're going to get into more complex topics, and we need those topics to be more clear-cut. But for right now, I do like being able to show you guys kind of a real-time debugging situation and showing how to think through these problems. So thank you guys for tuning in. I will see you in a couple of weeks from a new apartment, a new location, a new city. And we will go over how to go from there. So thank you guys for tuning in. Hope you guys had a good time.